It began, as many discoveries in astronomy do, with a flicker of light, an anomaly captured not by the human eye, but by a vigilant network of instruments that never sleep. In the first moments of July, the year 2025, a whisper reached across the digital sky. An alert from the Asteroid Terrestrial Impact Last Alert System, known simply as ATLAS. It had detected something unusual, a fast-moving object cutting through the heavens at an angle that defied expectation. To the untrained observer, it was little more than a point of light. To those who watch the stars for a living, it was something else entirely. A visitor, an enigma, a new piece in the ever-expanding puzzle of the cosmos. The first measurements placed it on a path that didn't belong to our solar system. The numbers, cold and mechanical, hinted at something extraordinary. Its speed, its trajectory, its very motion spoke of an origin far beyond our own sun. When astronomers ran the simulations, one designation emerged. 3I Atlas, the third confirmed interstellar object ever observed. That letter I stood for interstellar, an unassuming mark that carries the weight of cosmic scale. Before it, there had been only two. 1I, Oumuamua, and 2I, Borisov. Each had swept through our neighborhood like ghosts from another realm, leaving behind more questions than answers. And now the third had come, bearing mysteries that would soon stretch human imagination to its limits. But what caught the world's attention wasn't just the fact that 3I Atlas came from another star. It was where it was going. Its path threaded through our solar system with unnerving precision, past Venus, past Mars, then curving close to Jupiter, before vanishing back into interstellar night. When scientists calculated the odds of such a trajectory happening by mere chance, the number they found, just 0.005%, was almost absurdly small. It was the kind of improbability that makes even the most rational mind hesitate. Because if something happens against such odds, one can't help but wonder, was it truly coincidence, or was it design? At first, astronomers treated it as they would any comet or asteroid. They pointed telescopes toward it, recorded its brightness, its spectrum, its velocity. But as the data came in, patterns began to emerge that didn't fit neatly into the expectations of known natural objects. The way it reflected sunlight was odd, too uniform, too stable. Its acceleration, too, was slightly off. Subtle deviations, tiny irregularities that most would overlook, but which scientists recognized as the whisper of something significant. Some suggested outgassing, jets of gas and dust erupting from its surface, as comets often do when warmed by the sun. Yet others found that explanation lacking. The acceleration seemed too precise, too directional, as though the object were making course corrections. The mystery deepened when spectroscopic studies revealed a curious chemical fingerprint. The James Webb Space Telescope detected faint traces of carbon dioxide, but none of the organic compounds usually found in untouched comets. It was as if the object had been scrubbed clean, its surface smooth and controlled, releasing material not chaotically, but in measured pulses. It didn't behave like something wild and ancient. It behaved like something deliberate. And so, quietly, a question began to form, a question that had once belonged to the realm of science fiction, but which now tiptoed into scientific speculation. What if 3I Atlas was not simply a traveler from another system, but a traveler with purpose? What if it was not a comet, but a craft, not a relic of chance, but a creation of intent? Such a thought carries an unsettling weight, because to entertain it is to open the door to the possibility that we are not alone and that we have never been. The cosmos is vast, billions of stars, trillions of planets, and the odds that we are the only intelligence to emerge from that ocean of time and space are astronomically small. And yet, to confront the tangible presence of something possibly constructed by another mind is a different kind of reckoning altogether. It is one thing to imagine intelligent life. It is another to find evidence of it drifting quietly through our own solar system. As word spread through the scientific community, teams across the world began to mobilize. The European Space Agency, NASA, and observatories in Chile, Japan, and South Africa joined forces to track the object as it arced closer to the Sun. Every hour brought new data. Its velocity measured at 61 kilometers per second, its retrograde motion confirmed, its path mapped with increasing accuracy. It would reach perihelion, its closest approach to the Sun, on the 29th of October, 2025, after which it would slip behind the solar glare and vanish from view for several critical weeks. That period of invisibility became the focus of growing curiosity. Some astronomers, among them Harvard's Avi Loeb, noted that this alignment, hiding the object within the Sun's brilliance, was an almost perfect window for observation of Earth. Coincidence? Perhaps. But the odds were, once again, remarkably low. And so, even among those committed to skepticism, a quiet tension took hold. Imagine, for a moment, what that means. A visitor from another system, passing within reach of our instruments, perhaps even watching us as we watch it. If it were indeed artificial, if it had been sent here, then somewhere, sometime, another civilization would have chosen this trajectory, these encounters, this moment. And what would it be seeking? Knowledge, contact, warning. The questions multiply, each more haunting than the last, but the beauty of science is not in its answers alone. It lies in its willingness to ask, to follow the evidence, to hold wonder and reason side by side. Tonight we begin that journey together. We will trace the path of Three-Eye Atlas across the sky and across the boundaries of imagination. We will sift through the data, the theories, the hopes and fears it stirs. Because in the end, whether it is rock or relic, machine or miracle, it holds up a mirror to the deepest parts of ourselves, the part that still dares to look up and ask the oldest question of all. Who else is out there? When Three-Eye Atlas was first catalogued, the astronomical community treated it as a routine addition to a growing archive of near-Earth objects. The data was logged, its coordinates circulated among observatories, and telescopes across the globe adjusted their optics to track its motion. But within days, what began as routine observation became a global collaboration of unprecedented intensity. The object was moving fast, far too fast to belong to the family of comets or asteroids born from our own solar nebula. Its hyperbolic trajectory meant one thing beyond doubt: it came from somewhere else. It was interstellar. That single fact alone made it a scientific treasure, an opportunity to study matter formed under alien suns. Yet, as more instruments turned their gaze toward it, the narrative began to shift from curiosity to something far stranger. The Pan-STARRS Observatory in Hawaii was among the first to confirm its speed, roughly 61 kilometers per second relative to the Sun. To put that in context, the average comet originating from the Oort cloud drifts inward at barely half that velocity. The orbit of Three-Eye Atlas was retrograde, moving opposite the direction of the planet's motion. Such a configuration is unusual for natural objects because it implies an enormous amount of energy. It is as if this wanderer had not simply fallen into the solar system's gravity well, but had chosen its course with precision. Every time astronomers plotted its path forward, they found the same astonishing result. It would pass remarkably close to Venus, Mars, and Jupiter in sequence, each encounter occurring at geometrically favorable alignments for observation. The probability of this happening by random chance, according to detailed simulations conducted at Harvard Center for Astrophysics, was roughly 1 in 20,000. That number alone sent tremors through the scientific world. No known mechanism of interstellar migration could easily produce such a finely tuned orbit. Random gravitational scattering among stars would yield trajectories that pass wildly through the solar system, not neatly brushing three major planets. Avi Loeb, already a controversial figure for his work on Oumuamua, published an early preprint suggesting that 3I Atlas might warrant consideration as an artificial interstellar object, perhaps a probe or a remnant of one. The suggestion was met with both fascination and resistance. Many scientists insisted that natural explanations should be exhausted first, but as data accumulated, those explanations began to fray. The James Webb Space Telescope was the first instrument to resolve its composition beyond the limits of Earth's atmosphere. Its instruments detected a coma, a thin envelope of gas, but not the typical mixture of volatiles expected from pristine cometary ice. There was carbon dioxide, faint and measured but absent, were the organic signatures common to comets untouched since the birth of the solar system. No methane, no formaldehyde, no complex hydrocarbons. Even more puzzling was the pattern of its emissions. Instead of a steady release that brightened as it approached the sun, the outgassing came in controlled pulses, regular and uniform, as though regulated. One research team at the European Southern Observatory likened it to a mechanism venting in cycles, not the chaotic sublimation of natural ices. As the object drew nearer, radar arrays were brought online. The Goldstone Deep Space Network, usually reserved for tracking spacecraft, was repurposed to bounce signals off the visitor. The echoes that returned suggested a shape irregular, but not random. Unlike Oumuamua, which appeared elongated like a spindle, 3I Atlas displayed facets, flat planes that hinted at geometry. It was roughly 3 to 5 kilometers in diameter, far larger than its predecessors, and reflected radar in a way that implied either an unusually smooth surface or a reflective material unfamiliar to natural formations. The signals produced harmonics, secondary echoes that some engineers compared to the scattering patterns of composite alloys. No one could confirm that interpretation, but the data refused to behave like rock. By late August, the object had become bright enough for amateur astronomers to glimpse through mid-range telescopes. It appeared as a pale, bluish smear, moving steadily against the background stars of Sagittarius. Professional observatories tracked subtle variations in its brightness, fluctuations too precise to be explained by random rotation. The light curve repeated every 42 minutes, as if the object were spinning in a controlled rhythm. This periodicity gave rise to further speculation. Could it be transmitting? Could this modulation represent a beacon, a pattern meant to be noticed? SETI's Allen telescope array was directed toward the object, scanning across multiple frequencies. They detected no obvious radio signals, no deliberate pulses or encoded bursts. Yet the absence of transmission did not dispel the sense that something extraordinary was unfolding. When October approached, tension in the scientific world grew almost tangible. 3I Atlas was nearing perihelion, the point of closest approach to the sun, and soon it would slip behind the blinding solar glare. For weeks afterward, Earth-based telescopes would lose sight of it entirely. In that window of invisibility, anything could happen: outgassing, fragmentation, or even disappearance. NASA's Solar and Heliospheric Observatory prepared to monitor the region around the sun where the object would pass, but its instruments were designed for solar observation, not for tracking faint, fast-moving bodies. Still, researchers hoped for a glimpse. On October 29th, 3I Atlas reached perihelion. Its temperature soared beyond 200 degrees Celsius, yet instead of flaring into a spectacular tail like most comets, it remained eerily subdued. A faint corona of gas formed, shimmering softly in ultraviolet wavelengths, but there was no eruption, no plume of dust. Its restraint confounded expectations. A few scientists proposed that its outer shell might be composed of refractory materials, perhaps silicates laced with metals capable of withstanding intense heat. Others wondered if what they were witnessing was thermal regulation, an active control of temperature, the hallmark of machinery rather than geology. As the object slipped into solar glare, instruments on Earth fell silent. For 3 weeks, 3I Atlas was lost to observation, invisible within the brilliance of the sun. In that silence, speculation flourished. Articles appeared across scientific journals, each advancing theories more intricate than the last. Some focused on celestial dynamics, arguing that rare gravitational resonances might explain the improbable trajectory. Others reached further, imagining a device built to map planetary atmospheres, to scan for biosignatures, or to gather electromagnetic data from Earth itself. When it finally re-emerged in mid-November, the data that awaited scientists defied easy explanation. Its trajectory had changed, subtly but undeniably. The deviation was small, less than 1/10 of a degree, yet far greater than could be accounted for by solar radiation pressure or outgassing. The alteration suggested a force applied deliberately, a correction executed during its time hidden behind the sun. For the first time, even skeptics began to use the word maneuver. At that point, coordination among observatories reached levels unseen since the discovery of gravitational waves. NASA's Jet Propulsion Laboratory, the European Space Agency, and independent teams from Japan, China, and India pooled their observations. High-resolution spectroscopy from the Keck Observatory revealed trace elements, nickel, magnesium, and something else, an absorption feature around 200 nanometers that matched no known natural mineral. Some speculated it could be an alloy, others an artifact of observation. But in scientific terms, the anomaly was stubborn. It persisted across instruments and across wavelengths. The intrigue deepened when an analysis of reflected polarization suggested that 3I Atlas possessed sections of differing albedo, bright and dark regions aligned with mathematical precision. The orientation of these patches changed predictably with its rotation, forming what appeared to be a repeating grid-like pattern. It was not random, it was structured. And yet, structure alone does not prove artifice. Nature, in its complexity, has produced many patterns that mimic design. Still, the coincidence of trajectory, modulation, and geometry began to feel like more than coincidence. Harvard's team published an updated statistical model demonstrating that the object's approach vectors to Venus, Mars, and Jupiter corresponded to optimal observation windows of each planet's atmosphere. Venus's dense carbon dioxide clouds, Mars's thin oxidized plains, and Jupiter's magnetic field all would be surveyed within months by a single path. It was as if 3I Atlas were conducting a grand reconnaissance mission of the solar system, gathering data not at random but according to purpose. In December, as it neared Earth's orbit, the object passed within 167 million kilometers, close enough for detailed radar mapping, but far too fast to intercept. Some proposed a rapid response probe, a small spacecraft launched aboard a Falcon Heavy or Ariane rocket designed to slingshot toward it for a brief flyby. But by the time such missions could be readied, 3I Atlas would be gone, receding into the void at nearly 100 kilometers per second. Humanity, for all its ambition, remained too slow to chase the visitor. As it swept past, a curious phenomenon was reported. Several radio observatories noted short, narrow-band bursts of radiation near 1.4 gigahertz, the hydrogen line, a frequency long favored in SETI research. The bursts lasted less than 2 seconds, too brief to encode messages, and some dismissed them as interference. Yet their timing coincided exactly with the object's closest approach to Earth. The pattern never repeated. To this day, the origin of those bursts remains unexplained. By early March of the following year, 3I Atlas approached Jupiter, passing within 53 million kilometers of the giant planet. There, it encountered the powerful pull of Jupiter's gravity. Calculations predicted a deflection angle of just over 11 degrees, yet what astronomers observed was 12. That one extra degree implied another thrust, another intentional change. Some suggested that the object might be using Jupiter's field as a slingshot, conserving momentum as spacecraft do when maneuvering between planets. Others insisted it could still be natural, a fragment venting asymmetrically perhaps, but the debate only deepened. Around this time, theoretical physicists began to model possible propulsion methods consistent with the observed behavior. One hypothesis suggested directed outgassing, controlled vents releasing material to produce thrust. Another imagined electromagnetic sails, thin films interacting with the solar wind to adjust trajectory. These were technologies within the realm of human possibility, albeit still experimental. If 3I Atlas truly employed such mechanisms, it would imply a level of engineering at least parallel to, if not beyond, our own. The question that haunted the scientists was not merely how it moved, but why. What purpose could such an object serve? If it were a probe, what was its mission? The data it could gather from planetary flybys would be vast: atmospheric composition, electromagnetic emissions, even faint traces of technological activity. Earth alone emits a continuous symphony of artificial signals: radio, television, radar, and satellite transmissions. An object passing this close could record centuries of human progress in a single sweep. Then came a revelation from the University of Vienna. By tracing its entry vector backward through the galactic coordinate system, researchers proposed that 3I Atlas might have originated not from the spiral arms where most stars reside, but from the thick disk, a region populated by ancient stars more than 10 billion years old. If true, the object could predate the solar system itself. That possibility reframed the entire discussion. If it were artificial, it might not belong to any civilization alive today. It could be a relic, a messenger from a people who vanished eons ago. Speculation bloomed into philosophy. Were we witnessing a probe built by an ancient intelligence, designed to wander indefinitely, cataloging the evolution of younger worlds? Could its trajectory through the inner planets be part of an automated mapping system, one that awakens only when encountering certain conditions, perhaps the radio noise of a developing civilization? If so, then its arrival near Earth at this precise stage of human advancement might not be chance. It might be response. The implications were staggering. Every new observation, every adjustment in its orbit, added weight to the hypothesis that 3I Atlas might be a constructed entity. And yet science demands caution. Extraordinary claims require extraordinary evidence. Teams continue to model natural possibilities, tidal stresses, volatile stratification, micro-impact dynamics, searching for explanations that could preserve the sanctity of natural law. But even as they did, the feeling grew that humanity was standing at the threshold of something unprecedented. In laboratories and observatories, scientists spoke in hushed voices about what confirmation would mean. To prove that 3I Atlas was artificial would be to confirm that we are not the first intelligence to cross the cosmic ocean. It would rewrite the history of existence, expanding it from a single planetary narrative into a galactic one. Every discipline, physics, biology, philosophy, would have to adapt. Even the definition of life would blur. For an artificial interstellar traveler would be a form of life, though not as we know it. And so, as the object continued its journey outward, a quiet consensus formed among those who had studied it most closely. Whether machine or mineral, whether artifact or accident, 3I Atlas had given humanity something priceless, a mirror held up to our cosmic potential. It reminded us that the stars are not empty, that the distances between them are not barriers but bridges waiting to be built. And if, somewhere in its silent rotation, there lies a message encoded in the geometry of its motion or the rhythm of its light, then perhaps one day we will decipher it. Until then, we are left with wonder, and with the faint, persistent feeling that the universe, for the first time, may be looking back. To understand the magnitude of 3I Atlas, we must look not only at its data, but also at the instruments and minds that pursued it. Every discovery, every insight about this mysterious object is the result of an intricate network of visionaries, scientists, engineers, and dreamers, each driven by a profound curiosity that transcends their individual lives. They come from every corner of our planet, united by a single goal: to decipher the messages written across the sky. For them, 3I Atlas is not just a celestial object, it is a test of human ingenuity and humility. It reminds us that the universe rarely reveals its secrets easily, and that to reach for them is both an act of intellect and of faith. At the forefront of this pursuit stand the observatories that have become humanity's eyes on the cosmos. The James Webb Space Telescope, with its vast segmented mirror cooled to near absolute zero, has given us our sharpest vision of deep space. When its sensors caught the faint whisper of light reflected from 3I Atlas, astronomers experienced what some later described as a collective heartbeat. In those tiny fluctuations of brightness lay information about shape, spin, and surface, clues to the identity of a traveler that may have crossed the galaxy before our species learned to speak. But this search was not the work of Webb alone. The Atacama Large Millimeter Array in Chile scanned for molecular emissions, passing the delicate frequencies of carbon dioxide and possible exotic compounds. The results hinted at something elusive, materials unknown to our catalogues, perhaps rare crystalline ices or structured silicates formed under alien conditions. Meanwhile, the European Space Agency's Gaia mission contributed precise astrometric measurements, charting the visitor's position relative to background stars with exquisite accuracy. These data, when combined, told a story that grew more intricate with every new observation. A body both familiar and foreign, obeying the laws of physics yet hinting at intentions we could only speculate about. And yet, even among the machinery of modern science, it was human imagination that gave meaning to the numbers. Astronomers gathered in late-night teleconferences, voices echoing across time zones, debating possibilities with the fervor of philosophers. Some spoke of natural mechanisms, complex interactions of volatile materials and sunlight that could explain the apparent precision of its course. Others leaned toward the extraordinary, the idea that what we were witnessing might be the creation of another civilization, one that mastered technologies we can barely conceive. Between them stretched a spectrum of wonder and caution, the eternal balance that defines the scientific spirit. History, too, provides context for this moment. Humanity's first encounter with an interstellar object, Oumuamua, in 2017, was fleeting and ambiguous. Its unusual acceleration, its cigar-like shape, and its lack of a cometary tail had already challenged our assumptions. Then, 2 years later, came Borisov, a more conventional traveler whose luminous tale soothed the scientific community's nerves. But 3I Atlas stands apart. Its size, its controlled outgassing, its improbable path, all combine into something that seems to hover between the natural and the artificial, as though the universe itself refuses to be categorized. What makes this third visitor so compelling is its potential to transform how we think about contact. If it is artificial, it represents a mode of communication not through words or signals, but through presence. It is a silent envoy, a demonstration of existence, a statement carved into the fabric of space-time. We were here. For those who study astrobiology, this idea reshapes the question of life beyond Earth. It suggests that civilizations, once they reach a certain level of maturity, may choose to communicate not with fragile radio transmissions, but with durable artifacts capable of surviving millennia. These artifacts, drifting from star to star, become seeds of knowledge, waiting for new minds to find them. And so, scientists have begun to consider 3i Atlas not only as an object to be observed, but as a potential archive, a time capsule from a distant civilization. The notion is both thrilling and sobering. If it is indeed such a relic, what message might it carry? Would it contain information about its creators, their understanding of the universe, their hopes or fears? Or would it be something more abstract, a record of existence itself encoded in materials beyond our comprehension? We may not yet possess the technology to answer these questions, but the very act of asking them brings us closer to understanding our own place in the cosmos. The implications extend far beyond science. In universities and research institutes, philosophers and ethicists have joined the discussion, exploring what it means for humanity to discover evidence of another intelligence. If 3i Atlas is artificial, it may have been launched tens of thousands or even millions of years ago. Its creators might be long extinct, their worlds swallowed by the march of time. Yet their work endures, crossing the void to reach us. To encounter such a relic would be to meet the past of another species, to stand face to face, not with living beings, but with their legacy. And in that reflection, we might see the shape of our own future. For humanity, this moment serves as both a challenge and an invitation. It forces us to confront our fragility, our transience, and our potential. We have long gazed at the stars and dreamed of contact, but perhaps contact has already been made, not through words, but through shared curiosity. Perhaps civilizations across time have each contributed to a vast, invisible conversation, conducted not in sound, but in action, each sending something into the cosmos to say, "We existed and we wanted to be known." As 3i Atlas recedes toward the edge of our system, the efforts to study it continue. Space agencies are already drafting concepts for intercept missions, fast, lightweight probes propelled by solar sails or plasma drives, capable of reaching interstellar speeds. The goal would be simple yet profound: to catch up with the traveler, to image it closely, to touch it if possible. These designs, once the dreams of speculative engineers, are now being seriously evaluated. The possibility of direct examination no longer belongs to the realm of fiction. It sits on the horizon of technological feasibility. But even if such a mission never launches, the legacy of 3i Atlas will endure. It has already reshaped the priorities of astronomical research. Funding for interstellar object detection has increased dramatically, and new instruments are being designed specifically to identify similar visitors before they vanish beyond reach. The Virasi-Rubin Observatory, nearing completion in Chile, will scan the skies nightly, its vast field of view promising to reveal many more travelers from other suns. The discovery of 3i Atlas may be remembered as the spark that expanded our understanding of the galactic neighborhood, the moment when we realized that the space between stars is not empty, but alive with motion, memory, and mystery. There is, of course, another possibility, one more haunting, yet strangely poetic. What if 3i Atlas is the remnant of a civilization that perished long ago? Its voyage could be the final echo of a people who once reached for the stars, sending their creations outward as their world fell silent. In that interpretation, the object becomes not a probe, but a tomb, a vessel carrying the dust of extinct intelligence preserved in the cold darkness of space. If we ever uncover its secrets, we might find within it not messages of dominance or conquest, but something achingly human, the desire to be remembered. Such thoughts transform our perception of our own civilization. They force us to ask what will remain of us when our cities are gone, when our languages fade, when even our sun begins to dim. Will any trace of our existence survive the deep tides of cosmic time? Perhaps inspired by 3i Atlas, humanity will send its own emissaries into the interstellar dark, not to colonize, but to communicate, to preserve the essence of what it means to think, to dream, to love. In the halls of science, discussions have already begun about how to encode the story of humanity in forms that might endure for millions of years. Data crystals, quantum archives, self-repairing nanostructures, all are being explored as potential carriers of knowledge. The challenge is not only technical but philosophical. What do we choose to send? Equations, art, music, the DNA of our species? The questions themselves remind us that science and culture are inseparable threads of the same fabric. To reach the stars is not merely an act of engineering. It is a declaration of identity. As the object moves farther from the sun, fading from our instrument's reach, there is a quiet sense of reverence among those who have watched it. Some describe it as a feeling akin to witnessing a departing ship disappear over the horizon, a mixture of awe, melancholy, and gratitude. Whatever 3I Atlas truly is, it has fulfilled a profound role. It has reminded humanity that the universe is not static, not indifferent, but dynamic and mysterious. It has reawakened our collective sense of wonder, a quality as vital to our survival as any technology we may build. There are those who believe that 3I Atlas will one day return. Its orbit, though open, could be perturbed by encounters with distant stars, looping it back toward our region of space in tens of millions of years. If that happens, who will be here to see it? Perhaps descendants of humanity, perhaps new beings born of our machines, or perhaps nothing at all. Only the whisper of a species that once looked upward and asked who else might be watching. In a sense, it doesn't matter. The story of 3I Atlas is not only about what lies beyond, but about what lies within. It is about the unbroken thread of curiosity that stretches from the first humans who gazed at the night sky to the scientists who now analyze light curves and spectral lines. It is about the courage to face the unknown, to ask questions that may never be fully answered. It is about the recognition that even in the vast silence of space, meaning persists. And perhaps that is the ultimate message of this interstellar visitor. Whether it is a natural wanderer or an ancient artifact, it has served as a mirror in which we glimpse both our insignificance and our potential. It reminds us that we are participants in a story far larger than our planet, a story that began before we were born and will continue long after we are gone. In studying